You know what we gotta do before we do anything? We gotta log in Project Gorgon so I can finish my AFK questing. I hate this stuff. I hate Hangout. It's so dog shit. Can't hang out with her anymore. Does anyone else want to hang out here? Yetta? Want to hang out? No, she thinks I stink. Want to hang out? 4 hours? Let me check the other character. Can we find another 4 hours? You learn anti-drowsy cantrip. Human anti-drowsy cantrip, okay? 2 hours. Nah. Does nobody want to hang out for 4 hours? No, he doesn't. He just wants me to milk his cows, man. How about you? 3 hours. Might have to go with that. 4 hours. Perfect. I'm also making some tea. Now today we have to figure out what exactly is going wrong here. And I'm not really entirely sure. But it has to do with what I did up here. This. We have to figure out the correct way to engage with this. Should we say that this is gonna be the corner matrix it contains shorts, and Maybe I need to look up the algorithm again and see. But I think this might be kind of fucked. Yeah, let's wait a little bit. Let's sit. Because we have this, right? Dual contouring. See, the problem I have that I really don't like is that when we end up with this up here, we're kind of ending up with a scenario where if we maintain this logic, if I have one block, the block is at minimum 9 times 9. And no matter how small it is, or how small or large that one block is, the contouring will need to hug it, right? In order to make this box appear at all, we would need to have vertices all over the place here to create this area. And that's what's fucked. Because I feel like I need a block to be capable of being self-contained. But that would mean that each block would need the capability to contain 12 sides. And then we're back at what I was doing before. So the question is, what kind of logic can I use here? What if we actually calculate this stuff? What if we say that this is 3, 0, 0, 0, 0, 0, 7, 7, 7, right? Then in order to calculate this, we do zero plus 3 plus 7 plus 7 divided by 4, which is going to be 17 divided by 4. which is 4, right? Then up here, this one is going to end up being 0. This is 4. This is 0. I think this is a bad example. Let's say that this is a 5. Then we'll get a value. So then instead it's 19 divided by 4, which is still 4. And then this is gonna be 1. This is also 1. This is also 4. Wait, that doesn't even work. Five plus 7 divided by 4 is 4. Yeah, that doesn't work. Should it actually be corner minus source? Because I'm doing source minus corner. Because otherwise you're telling me that this can never be represented. This will just end up being... like this will be drawn instead down here. What if we say we've got something like like this. And then we also have here and here. And then we say this is 4, 3, 3, 4, 2, maybe 7, 7, 7. Then this will be 21. That's gonna be 5. And so will this. And these up here, this would be 3 plus 4. This is gonna be 1. And this will also be 1. These are 0. So you're telling me that if I do... Because here, what I'm doing now is source minus corner. And if that's -1, or if it's below 0, then that means that we're inside. But what that's showing here is that it can only be inside if the source is 0. If it's ever like 3, 4, 3 here, it doesn't work. So it has to be the other way around. It has to be target minus source. But I'm not sure that's really gonna yield any results just like that, because I've already tried that once. It looks okay, I guess. Now it's the issue of the corners. And now I think maybe it's okay to do the corners the way I was doing them. Perhaps. I've never had this happen before, though. That's a little interesting. Oh, okay, I did see this once. But it doesn't really seem to solve much either. Either way, it's all fucked. See, it's leaning in the wrong directions and everything. So we gotta figure out where is the lean being handled, and why is it always going in the opposite direction of what it should be doing? Because it seems to genuinely be doing the opposite. It's doing nothing, or it's doing the opposite. Because, well, here actually, like, here it's actually 7. Like, the volume here is 7, 7, 7. Which is a little strange, actually, but it does say that it's 7 here. And here it goes down to 6. So it might not be wrong, actually. We are exactly at the peak. And here it goes down to 6, but yeah, you can see here it just collapses. It collapses and it like goes down underneath somehow. which is also very interesting. Because I don't understand how that can really happen, other than if this is missing, which, if we look, actually it shouldn't be. See, here it's a 7, 7, 6, and it just says 7 still. It just goes down to 0 for some reason. And I think it's because here it's all 7s, and then the second there's the transition, for whatever reason the corner is causing this to like implode. And then this one is just all 7s. Even though the voxel volume is 6, they're still level with the everything here. Which is highly questionable as well. Then here, we have 7s here. The 6s are all 7. But then we go down to a 5. And now it plummets down to 5. And then here it goes up to 7 because this is a 4. So, for whatever reason, the verts are somehow the corner values are just wrong. This is so hard to bug test. Am I dumb again? Like, if corner volumes minus volume contents is less, Like, it doesn't work either way. Maybe I should skip zeros. Because I don't really know how to handle this scenario. Like the one vertex. How do you handle a lone vertex without having to create 8 vertices around it? I don't know if dual contouring handles that. It doesn't. I mean, it could. Here's the problem, right? If I subtract the corner from the source, then we just end up with a positive value. Maybe that's what I need to be looking for. Maybe we're looking for a positive value. But that doesn't make sense either, because then this 7 here would also count as a corner here. Which I don't know if it should. And it also, it's just not right. That's what's so hard here. But and these two are actually different now that we look at it. Here it's 5-4, here it's 5-4 the other way around. Fuck. I mean, the 7... I feel like this should exist. Like, this corner should exist. This corner should not exist. But what rules do I use to call this without calling this? That's what's impossible. How do I draw one voxel with dual contouring here. You just kind of can't. So here's the problem, right? If we have one block, the minimum size we can have is this around it. No matter the volume of this block, we always have this. It's never bigger, it's never smaller, no matter what. And if I create a series of blocks, if this block here has like a volume of 4 or something, I don't know what 4 looks like that maybe. What we'll then get is this. But when we get to here, we can have a block, a pixel be like here, and then we'll get this, I think. That's what we'll get there. And that would be okay. And we would need a minimum of this to be able to have a size. Right, because if we have this, then we can have... So it's kind of weird, right? Because if I have one row of voxels that have a volume of 1, then we're gonna get this. And if I then add another row with a volume of 1, we're then gonna get something more akin to this, right? It's gonna be something like this. So 2 1s is like 1/8, no, 1/4 the size of a full voxel. Or rather, 2 1s is 1/4 the size of 1 1. That's how it should end up. And that's what's so weird. That's what I don't like. I want to find a way to be able to have one lone voxel. But I think the only way to do that is to store vertices for each. What am I doing right now? What idea was I working on? We have three vert fields. Each vert field contains 3. So I have 9 right now. Doing 12 wouldn't be that big of a leap. Wait, do I need 12? Why do I need 12? You only need 8. It's 12 for having a vertex. Yeah, okay. I mean, I don't know. It's 12 to have a vertex in the middle on each side as well. And I think I do need that. Kind of. Like, not really. Yeah, I do need that. But that would mean that it would need to be target, the corner minus source. And the reason we need a center point is that the center point is actually you know what? It could be done with 9. Now that I think about it. Because the center point is... That's the vertex. That's how it works. We're creating a surface net by tying together the central vertex of the voxel with its neighbor. But the reason I need to have more vertices inside of the voxel is because the voxel needs to be self-contained in terms of its data. Otherwise, I'm gonna have to calculate things on the fly, and that's gonna suck, right? So it's either that or like do meshing. And if I'm doing meshing, then why am I ray marching? Right? But yeah, what I could do is we could say that if this is 7, okay, let's look at this first, right? Let's make a central block here. Let's say it's 5. This is 5. Then this these are all gonna be 1s. 1, 1, 1, 1, right? And the way it could work is that instead of checking inwards, we're checking outwards. Maybe that's what I should be doing. We're not checking for density, like, we're not checking for surface, we're checking for... Oh, we are, but... that could work. And then if we take the source, which is 5, minus 1, and we say... Five minus 1, that's 4. So then we are at a higher value. That means that this is inside. But if we have down here, we have a 7, and we do 7 minus 5. Yeah, it doesn't work. Because then, while we can do that here, like 7 minus 1 or 5 minus 1 is 4, and then we can say, okay, this is a surface because it, you know, whatever is out here is actually higher. But here then we have 4 and 3 up here, and it's obviously that this is where the surface should be. But here we get a 5, and if we subtract 5 from 7, then we have a 2, and then this becomes like a surface? That's not right. So... and it's the same thing even if I do it in reverse. Fuck. Because it's a problem everywhere. Like this here doesn't work. I can't have like a lone 7 either. It doesn't work. Maybe this corner system is just fucked. I don't really know what to do about it. The averaging of the corners creates a density. But the issue, like, it works. It does. But the issue is that it doesn't properly represent the world in the way I want it to. Because this 5 here, if it's source minus target, then this voxel doesn't exist. Like, it counts as not being thing. Meanwhile, these do, because this is 5 minus 4, this is 0 minus 1. Right? And that's retarded. But I wonder if upping the value to 8 would do something. Because in reality, it's a value from 0 to 8. 0 just means that it doesn't have anything. And then it's 1, 2, 3, 4, 5, 6, 7, 8. Because the zero is included, right? But I'll be right back. It might be an angle like, instead of skipping anything that has a volume of 0, we skip anything that's an air tile, because we actually know what they are, right? So here, I was doing some bullshit here where we were skipping, but what we can say here instead is source index equals voxel matrix xyz dot voxel index. we can actually say, what is that? It's voxel index. Then we can say if source index equals voxel index dot air, continue. No, return. That's one way of handling this. That way we cannot draw a voxel vertex within this. It has to be one of these. But I do think that we need special logic either way in that scenario, because we have effectively fixed this issue now. But I do think this problem remains, however. This 5 here, it doesn't work. This 4 works. 4 minus 5 is minus 1. So here this exists. 5 minus 4 is 1. This doesn't exist. But we know that it exists because that's what's frustrating, right? Because this is surface. So how the hell do I deal with this? And I'm just wondering if... What if we say that these are 8s? Does that solve the math somehow? I kind of doubt it, but... Zero plus 5 plus 8 plus 8. That's then 21. Divided by 4 equals 5. But that's still a 0. And that doesn't actually result in a hit. It needs to be negative. So I'm just not so sure how to handle this. Because the reality is, if I skip this air tile, then it doesn't work either. So we can't actually skip air tiles. Air tiles need to exist. I feel like this is kind of fucked. I know I'm kind of approaching this in the wrong way, to some degree. Because look, here, this is retarded. Because here, this is a 4, this is a 0, 0, right? And so what's happening here is that source minus target means that this, none of these corners count for the 5 here. But the 0 has a corner here. Which means that this voxel doesn't exist, but this voxel exists. That's giga retarded. Like, this just straight up doesn't work. For how I am doing this. And I was thinking of, like, how else can I do this? Because I was thinking I could get the average of this, because this is creating a density, right? So I'm trying to create a density, like a density thing, really. But if it's source minus target, it would have to be drawn up here. Because this is 0, 0, 0. And then here we have 1. So this is the surface of the density itself. But that's because the density has been moved to be up here. And that sucks, right? So if we try to skip air tiles or something, it's still gonna be fucked, because if I try to, like, maybe add all of these together and get the average for the center, which doesn't really make any sense in my opinion, but, you know, kind of. What would that end up as? 10 divided by, like, it's gonna be 2. And here it would work. We would have a 2 here. 2 minus 1 is positive, so this is whatever. But then here, 2 minus 4, that's negative. So that would work. But then what about down here? This is a 7. We have to determine whether this is a surface or not, right? So 7 minus 4, that means it's not a surface. But 5 minus 1 also means that this is not a surface. 5 minus 4 means this is not a surface. So if we take the average here, what's that? 4, 4, plus 7, 14, 22, divided by 4. That's 5. Okay, so the value here is actually 5. Actually, it doesn't work. Now, 5 minus 7, that's negative. So that means that this is also a surface. So now we have a surface here and a surface here. It doesn't work. It has to be done in another way. It has to be done in a way that doesn't use my new corner system. I think we have to scrap that entirely. It doesn't fucking work. It has to use its neighbors somehow. But I don't know how to implement that into the contouring system. Because it's no longer about corners. Like, I don't have a corner. We have neighbors on all sides. Oh, I'm never gonna get this engine functional. Holy fuck, this is so fucked. There's not a single system that does what I want. And I cannot really figure this out. Holy goddamn shit. Or it's either that, or we like entirely give up on the original system. Because the reality is the whole system kind of revolves around this here. Because I feel like I'm trying to force a meshing system into a marching system. Just don't know if it's gonna work. Like, it's so close, but it's so far away. Just thinking of how this could be done. In a different way. Because one of the core things that we need is the ability to render one voxel. But the way dual contouring really works is that we're gonna be checking like these tiles, kinda, or I don't know. This was how Lin was doing it. Like you check like this, and then you check these, and then you check these, and then you check these. And what you're doing is you're checking all of these tiles, and you're determining where this vertex is gonna be. We're determining the corner, right? And I feel like that could work, but the issue with that is that it's not tied to the voxel system. Like, this just creates a mesh. And that's kind of useless to me. But what I'm thinking is that I could potentially use this by storing the mesh like inside of the voxels. What I mean with that is this, let's say we have this here, right? Then we'd end up with voxels like, I don't know, here probably. Because I don't think it wouldn't become a circle, it would become a small square. I would prefer a circle, but a small square is okay. This is a super edge case anyway, so who cares? Kind of. I care a little bit, but... What I could then do is we number them. So this is like voxel 1, 2, 3, 4, right? We'd have to have an allocator for that, because it could be like, this is number 4, and then it gets removed, and then it gets re-added again, and now all of a sudden it's number like 43, or like 200, or whatever. Like whatever slot was open in the allocator. And then each, they just contain indices. Like this is vertex 1, 2, 3, and 43. That's all it contains. And then we have a buffer that just contains those vertices. And then we know that in order to render this, we need to load these vertices. However, I don't know if I could, like, how to order it. I'm not sure if I could order that in a way that makes sense. Maybe. Because then I could just load, because each voxel or each vertex would contain the index of its links. So this one would contain 1, 3, 43, 2, but it would also contain the ones for its neighbors. Which might not work out because it might be too many values. Because I don't know, like, how many vertices might we end up with? Like 1 million? And at that point, we're already using up quite a lot of, like, an integer. So it might still be a lot of data to store. Like, let's say, what's 1000 times 1000 times 400? That's 400 million. That's a lot for one 32-bit integer. It would be doable, actually. It would be doable. Except that this would be about the value range that we would need for each number. We do have a value range of up to 2 billion, which means we can use fit like 5 numbers, which isn't nearly enough. Well, that idea is fucked. Bro, I don't know how to do this. I genuinely don't know. Any solution that I can really think of right now just kind of leans more towards a marching cubes implementation, but marching cubes are bad. Like, I feel like dual contouring would be good if I could make it make sense with lone voxels, which it just doesn't. I feel like there's like an actually logical solution that I can see in my brain. But it's also like not at all. Because I've already gone through that whole path. And it's not simple. It's like a question of, do I do what I was doing before on the GPU side, but on the CPU side instead? It's basically like calculating all the neighbors on the fly. I feel like it could kind of work. Because on the CPU side, we can always check our neighbors without cost. Because, I mean, of course it has a cost, but it's like the difference is checking all of the neighbors every render call for every pixel, or checking every neighbor when we change the tile or we change the voxel, and then we set some things. Because that's what I did before. I basically give each voxel its 4 vertices. No, it's 8 vertices, because every voxel is a cube, right? So every voxel has 8 vertices. And then we simply calculate the vertices in relation to its neighbors. And we just like hard set them that way. And then we just store that, send it to the GPU, like that. That's like the only way for the voxel to be self-sufficient, because it has to be self-sufficient. And that basically, I think that might mean dumping contouring entirely. Because I feel like right now, like, any of these algorithms for terrain smoothing feel like they work, but they're imprecise. And it's annoying. I don't like it. Like if you have one voxel here, just one, like it would work, but it's the only way it can work is by creating a mesh here around it. But I feel like that doesn't work with marching. Like this only works if we're using meshing as the rendering method. If these vertices like end up over here. Because that's kind of how it is, right? Like the vertices, at least I think so. Like you check these, and then the vertex ends up somewhere within this space. Right? Like the voxels get displaced vertically, or diagonally, kind of. So we're creating corners out of the voxels that exist. And therefore we're going to end up with something that looks like this over here. Right. But, like I said, if we are using marching, the only way I can get this to work, more or less, is to do this. By making each one of these air tiles contain the surface. And what I don't really like about that is that it kind of conflicts with facing other blocks, I feel like. And I feel like they're gonna start like bleeding into each other a lot. And then there's this issue with this scenario where you have a lone voxel here. In my current implementation, this voxel cannot exist. Because it has two empty neighbors. The algorithm cannot detect this as being the surface, because the average of these tiles, or these voxels, I mean in this case they are tiles, is 4. So 4 minus 5 is 1. So that means this is outside, right? Like the bottom corners are outside. So we don't actually get anything here. This cannot represent anything really. Because this was me trying to like adapt the meshing algorithm into creating like a mesh internally within the voxel that I can read using a marching algorithm. I'm not feeling that it's actually working. have any more tea. Or is it all ogre? No, we have some more. But I do think that what I was doing before kind of works. But we do still have to create dummy tiles, which I'm not a huge fan of. And I'm not exactly sure how to handle it. But because it's the same thing, like when we were trying to do this, like this empty tile here would need to contain a part of the grass, so to speak, or the dirt, or whatever it is, in order for this to be able to be a smooth curve. And if I go back to like manually setting this, that's still gonna have to be a thing. And I'm not really sure how I want to handle that. I think we'll have like a 0 for air, and we'll have a 1 for like an intermediary tile or something like that, like just a connective tile, which doesn't really count as a true tile, but it just reads as not a 0 in order for the march or the ray marching algorithm to be able to find it. But it's like it's not actually grass, it's just an intermediary. Which isn't necessarily true either, because I guess for the marching algorithm it doesn't matter. But it does matter for the logical side of things, because and that's where it's difficult, right? Because having this fake grass here means that you can't like dig it and get grass necessarily. I mean, you could, kind of. I don't know. Oh ho ho, every time I log on, this diagram is more complicated than last time. Yeah. I don't know. I think I have to give up on this approach. There's nothing wrong with the approach, and it actually works, but it doesn't work with like the details of how I want it to work. And I don't think I can get it to work the way I want it to work. So we might have to try approach number, I don't know what we're up at now, like 7, maybe? Instead. And we'll see, I might be able to copy paste a lot, because the solution I think I'm gonna try here is the solution I already programmed fully for the shader. And it's a lot of code actually. But I think we can just convert it from HLSL to C#. And it should be fine.
But yeah, dual contouring, I think it's probably a pretty good algorithm, but I don't think it really fits ray marching that well. It's more of a meshing approach. It's more of a way to mesh your voxels rather than a way to get like, because I was trying to do that obviously, but I was trying to implement it together with ray marching, and I feel like they don't like each other. And it's a little imprecise. All right. What should we look at? Public, void, calculate. Voxel config or something, I don't know. I don't think I still have it here. No, I have to go and find my backups. Is it on my desktop? Yeah. I think it should be that. But let's see, is it implemented at all here? This is the bad one. What's in this one? T. That's a lot of comments. Everything here is commented out. Is this actually worked? Somewhat decently? But I think we want to go with this one. Go to the bottom. And where's the start of that? There. Let's see if this is everything. But it's a lot. But there's a lot of comments and stuff too. Not that much actually. You can see it's like over 1,000 lines of HLSL code. E2. So we want float. No, it's a vector 3, v0, v1, v2, v3, v4, v5, v6, v7. I think that should be all. And then this is different. Yeah, I can't actually do replace all here. So this is just brute forcing it, really. This is just checking the neighbors of every voxel and then just comparing them and taking the averages and then just setting like the internal vertices of the cube. That's it. It's just brute force. But this was what worked the most, but it ran like ass. And it had so many random issues. Here we have voxel data. The voxel data here just needs to be replaced with XYZ access to the matrix. Let's just focus on the floats first. We're like 20% through. I just hope that this is the right version. But this... it'll work. It'll work. But right now it's set to floats. And it can't be floats. We have to limit it to the coordinate system. Which right now should be a value from 0 to 7. I think it should actually be a value from 1 to 8. So we'll see how we'll do the math. But the voxel only has 8 steps of internal positioning, because that's a 7 and 7 is 3 bits, and I didn't want to use more. Because I don't want to use 32 bits times 3 times 8 for all the vertices and all their coordinates. Oh, that's the end. All right. Cannot convert double to float. Oh, okay. Actually, 0.5s might be replaceable. Let's see here. What we need is a value. So we need an int x, int y, int z. And I think that's all it needs to take. And then we need to say voxel data 111. If we do that, the voxel contains an alignment matrix. I've commented out the voxel alignment. But I think we might need that. It's baked into the volume contents. I do still think we want to bake things into integers because it's still a lot of data to store. So we need to say voxel data 111. Oh no, I don't want to do this. I feel like I gotta replace. We can replace all voxel data 111. It's still annoying to do replace all because it's so much shit here. But we can say voxel data 111 can be replaced with voxel matrix x, y, z. Yet we can't get the alignment. But here it says alignment x equals -1. Maybe I can make something here. We can say public vector3 int get alignment return new vector 3 int. And then here we're gonna say x is alignment matrix 0. How does it work? If okay, we're gonna do this. This is what we're gonna do. Instead of trying to do like casting with booleans or whatever, we're gonna say if alignment matrix 0 1 1 is true, then 1 else 0. And then what? Minus alignment matrix 2 1 1, then 1 else 0. Is that what we want? And basically what that means is that if the alignment matrix is true on the left, then that's a 1. And if it's true on the right, then that's a 1. And that means that if both are true, then the alignment is 0. And the alignment is basically, is this aligned towards a neighbor? Because if you have if a voxel has a neighbor on one side but not on the other, then it's shifted in towards that voxel so that they're squeezed in together. It becomes the surface. But if both are true, that means that it's squeezed between two, so it's not the surface of either on x. So 1 minus 1 is 0. And if it's I think it should be right minus 1. It should be like this, I think. 2 minus 0. That way, if 2 is true, wait, no. If 2 is true, wait. No, I'm retarded. If 2 is true, that's on the right. Then we have 1 there. And 1 is positive, so that means we are aligned to the right. While if the left is true and the right is false, then we get -1, which means to the left. Yes. God damn. And then here we need to replace these with Y and Z. And then we can return the alignment, like that. Without having to actually store it. And then we can just say get alignment. And more than this just running poorly, the issue with this on the GPU side was that actually I don't really remember what made me abandon it entirely, but the main issue is that the sheer amount of calculations that need to be done just stalled the GPU. Like we just run out of registers and it runs like garbage. So that can work. But I feel like we should be caching here. So let's just say vector 3 int alignment equals voxel matrix x, y, z dot get alignment. Because here we can cache here. Caching sucks on the GPU apparently. And here it's different all of a sudden. This is if voxel contents 110 means towards me does not equal 0, that means that alignment.z equals -1. And here it's alignment.z equals 1. Pop alignment y equals 1. Setting corner averages. There's just so much here that I cannot really remember which part is actually something that is like real. This can be multi-threaded though. Needed. Because we're only reading the neighbors, but we're only editing the well, actually we would need to create pending assignments because the neighbor might be reading the one that we're editing. So here's what we're gonna do. We're gonna go through this semi-manually here. We need to go down here and we need to say voxel data 100 Fuck. Escape cancelled too much. Escape is too powerful. voxel data 100 translates to voxel matrix x, y minus 1 and z minus 1. And then let's go and see what else we need. But here we have voxel data 101. That translates to -1 on y. 45 occurrences. But next, voxel data 121. That translates to +1 on y. Next up, 110. That's -1 on z. Voxel data 112. That's +1 on z. Any more here anywhere? A lot of errors disappeared. There's one. 011. -1 on x. (211). That's +1 on x. (120). That's 0 +1 -1. 3 occurrences only. Fuck. (102) +1 -1. (1 to 2). I don't know if I really... I don't know if I should cache this, because I am accessing them over and over again. So it's probably best. But it does mean caching the entire voxel, which might not be that big of a deal. But that does mean garbage collector, I think. -1 -1. There's like 27 variations here, so there are quite a lot to go through. Because this is for every neighbor. And that's 9 times 9. Oh, no, it's 9 times 3 -1. That's 26, I think. 210 +1 -1. (012) a sudden cringe. How's it going? Oh, plus. Two, 1, 2. Plus. -1 -1 there, -1 there. I'm alright, hope you're doing okay as well. I'm doing better this week. Last week was real bad. Like, it wasn't like horrible, but I was completely out of it. I'm still feeling kind of tired this week, but it's much better. Much better. But we will be taking a bit of a break again this weekend, because the new Path of Exile League is coming out. And I'm just gonna play that for a while. And I just wanted to get some programming in while I had the chance, to not let it completely turn to dust in my mind, which it already had almost. Are we done? Here we have some bullshit. Unfortunately, I think I need to do it again here. Because here I'm checking voxel instead of volume, or instead of voxel data. Did you see the game Octopath Traveler 0? The game looks pretty, doesn't it? They look okay. I'm not a huge fan of it personally, but it looks okay. I didn't look at 0 specifically, I just assume it looks exactly like the other ones. They have like good bosses and stuff. I'm just not a huge fan of, which is gonna be ironic, because I'm not a huge fan of that mixed 2D 3D style that much, and I don't like how they do like lighting and stuff. It like completely crushes the colors on the sprites. But otherwise it looks good. But also because I'm planning on doing the same thing here. But I don't know if I will be able to. There are a lot of issues that I can't really solve, so we'll see what I end up doing. Like, I wanted to have billboard trees and stuff, but the issue is if I do that, then I can't like really make the trees have any kind of physics or anything like that. The way they cast shadows will be fucked up, and there's just so many issues with it. I don't know. I might have to do 3D trees. I'm not sure. I haven't gotten that far really. I know how I want the... I know I want it to be voxels, I know how I want that to work. But the details of how I want to solve everything are like artistically when it comes to all of those kind of things, it's not decided. Really depends on what works, I think. I don't really want to learn 3D. That's why I kind of don't want to. Have to learn to like model trees and shit. But everything is kind of problematic. Even combat is kind of annoying, like I would like to have more like complex melee combat. But how do I do that? Like I can do it. I can do the logics very easily. But how do I do it in practice in terms of like art assets and stuff? Because I can make like the first person view, like sword effects and all of that. But what about like other characters being able to do that? If they're gonna be Billboard, then they're gonna need to have at least 4 directions. And then they're gonna be able to do like a bunch of complex animations in a bunch of different directions. And if I then want to combine that with like being able to wear different kinds of armor and stuff, it quickly becomes horrendous in terms of workload. But at the same time, like I said, I don't want to learn fucking 3D. Like, I think I would, like, okay, I hate working with Blender. I want to blow my brains out every time I open the program. But I think I'm, like, I have no doubts I could do it. It's just... It's a skill set that I don't know if I need or want. And learning things is super annoying. I do not enjoy the learning process. -1. I only heard bad things about Blender. Yeah, I don't doubt that Blender is powerful and can do what you want it to do. But it has the same, like, logical design that, like, GIMP does. And it's like everything that you've ever known about like how programs work or how like layouts work in any art program or like how Windows works or like anything like that. None of that translates into how it works. So every single time you try to do something that feels logical, it's not logical at all. It's like, no, we have a special Blender way to do it, and you have to do it that way. And it's impossible to like intuit how anything works. You have to watch like tutorials to learn it. It's terrible. Hate it. It's like, if I can give an example from another program that kind of represents how I feel about Blender. I was doing some stuff with, what is it called? It's that video editing program we're using now. Blackmagic Design, DaVinci Resolve. I was using DaVinci Resolve and I was trying to just cut a sound file that I had, like I had put it in the timeline. I was just trying to cut it in a certain point so I could just delete whatever came after, right? And at the bottom it has like a bunch of buttons that switches over to different modes. And one is called cut. And it has an icon of cutting a fucking thing that's in the timeline. So I go there, I click cut, and then I select this space where I want to cut. And then there's a button that says cut, and I click cut. But it doesn't fucking cut. That's Blender. So instead, because it's like, no, this is an audio file. You can't cut an audio file. You have to go over into the other section called like Magical Twinkle Land. It's called something like that. I don't know exactly, but it's called something like that. You have to go over there, and then you have to find another special function that's called like splice or like eraser. And then you can cut the audio file and delete it. That's how Blender feels like all the time. It's terrible. Yeah, no, it's terrible. It's same thing with like learning new art programs. Even if the new art program is good, it's like you're used to it. And like in Aseprite, I've rebound almost every single key to something else. And that means that like, well, even just switching over to from default Aseprite to like default Clip Studio Paint, everything is in the wrong place. The lasso, the move layer, everything is in the wrong place. And that means I have to sit there and like go through all of the key bindings and swap them over to exactly what I want them to and stuff like that as well. Normalized value. I think normalized value is a float. Equals 0. DaVinci Resolve could do a lot, but it was all easier in Sony Vegas 10 years ago. Yeah, like we're using DaVinci Resolve now for the studio. And that's because we have people who are actually like proficient in it, so they know how to use it. And it's the same thing there. Like I don't doubt that we can do good stuff with it. It just feels so ridiculously unintuitive. You just gotta learn everything. There are just so many things that should be like, it should just make sense. Like opening up a video editing program to cut something should be the most easy thing in the world. It's like you select a spot, click cut, it's done. I don't understand how you can do it any other way. and think it makes sense. Alright, what next? Hey. Everything here that says dot alignment is now dot get alignment. Volume. What is that? Volume contents? Yeah. Dot volume equals dot volume contents. No, not current document. You fuck. $418 occurrences. Is that accurate? Yeah, I think so. Anyway, I'll be right back. Can only use it for guitar videos, and even just putting two videos side by side is entirely too difficult. You have to adjust XY sliders instead of just click and drag. Yeah, maybe. That might be true. I don't think I tried doing that. It felt pretty, like, at least doing that felt, like, okay with the audio, but... yeah, like, even just basic stuff is too hard, for sure. Everything would be easier in Vegas. Yeah. I mean, I've tried Vegas too, and that did feel pretty straightforward. I've tried pretty much all of the free software now, and they're all really, really bad. It's almost It's unironically almost easier to work with FFmpeg than most video editing software that doesn't cost like $400. I haven't used Vegas since I don't know when. I haven't used Vegas since it stopped working on like Windows 7 or whatever. Like, I don't know. Like, I have that ancient ass version that they gave you almost for free on Humble Bundle like 100 years ago. That's the Vegas version I have. Actually, no, the issue isn't that it doesn't work on Windows 7. The issue is that it like only opens AVI files, maybe MP4. It can't open like any other file formats. I think that was the main issue with it. So where are we? Volume contents. Cannot convert double to float. Okay. This is gonna be, I think, really difficult. But we will try. And like I said, I don't know if this is the correct version, so some of the operations here might be incorrect. How did this happen, man? This could also be fixed. We're almost through, whatever. Alright, it's done. No errors. It's that easy. Except it's not that easy at all, but whatever. And this here. Fuck. To scroll down so I could see which bracket to remove, but fuck me apparently. That one. What else do I need? I Once we're done here, what we need to do is we need to set all of this in the voxel matrix, or in the voxel itself, and it has this volume contents value, right? That's just its volume. So we could do something like this, like the vertex container. Seven times 3 times 8. It's 168. That's a lot of stuff. But we can do more complex stuff here. Like we can actually cull the vertices that don't exist, but that doesn't really help us because each voxel still needs to be able to contain the max amount. So culling would only really help for storage on the C# side. But there are still tricks that we could do here. Because I'm thinking there's gonna be... We could make like a bunch of presets for each vertex position. So you can have one vertex that's bottom left, bottom right, top left, top right, top away, you know, whatever. So you can have like a default. That, because that way you could skip storing 2 vertices or 2 axes per vertex, because each vertex will only actually no. That's not true. It won't necessarily. Or maybe. I think each vertex might only ever be moved in one axis. Even when we have like triangles and stuff. Unless there ever needs to be like a central vertex. But I'm not so sure that's the case. I think we might stop here. I'm a little sad. I felt like I had to drop this method because I felt like this had a lot of promise, and I did feel like this was the right approach, but it kind of ended up not being that long run, just like the other ones. And that's how it always ends up. It's like it looks good, it looks good, it looks good until it's like 95% done. Like you saw before when I actually had like the terrain like almost functional. Like I've had that functional like 3 times now, and every time I run into a small little detail that makes it not work. Like when I did this approach that I'm doing now the first time, eventually it just turned out that when you have a diagonal block, it doesn't work. Because it needs to have, in order for the terrain to be like properly smooth, you need to be able to have a block in between that's like a fake block. And I actually don't really remember exactly why I dropped it, but it had to do with that. And then I did this solution, which, oh yeah, no, it's also that the oh shit, we're gonna run into that again. But on the CPU side, it should be easy to fix. We just need to actually calculate it. But basically, the issue is that we have to split the triangles in some direction. And we ended up with scenarios where it was like undoable. So we might have to increase the vertex count by 4 so that we can have a central vertex. I think that might be the scenario that we might have to adopt here. Because if you have a central voxel, then you can bend and shape the plane any way you want. But if you only have this, then you can't. Now we can only flap this along this line here. And in some scenarios, there's no actual real correct choice either. So but yeah. I'm gonna save that. That'll be that for today. Tomorrow, programming stream in the morning, as usual. And yeah. Until next time. Thanks for hanging. Have a good night. Bye-bye.